In this brief video, we'll try to see what is angle of friction and how it is related to coefficient of static friction that we have seen in prior two discussions. Let us consider the rough surface as shown over here. This is the rough surface over which a block is resting, and the rough surface is inclined at a small angle theta 1. We know that if there is sufficient friction available over here, for small values of theta, the block does not slide down. Let us say that when the angle of inclination is theta 1 as indicated over here, let us say the block is not sliding down. Okay, when theta is equal to theta 1, the block is not sliding down. Let us slightly increase the angle of inclination to theta is equal to theta 2. We have slightly increased. Here the block is not sliding, and we slightly increased. The block is still not sliding down, and we'll further increase it to a value theta is equal to theta 3. We have taken the values of theta 1, theta 2, theta 3 in increasing order. We further increase it to theta is equal to theta 3. The block is not sliding down. We keep on increasing the value of theta till the block starts to slide, or sliding impends at some particular value of theta 4. This value of theta 4 we represent by phi, and we call this phi is the angle of friction. So the angle of friction is the angle of inclination at which a block placed on the inclined plane impends to slide down on its own gravity. Okay. What is clear here is the word impend. Impend means that the block is just about to slide down. If the angle of inclination theta is any lesser, slightly lesser, the block does not slide down. If the angle of inclination is slightly more than this angle of friction, the block slides down. That is, with small variation, sliding or no sliding is happening. If such is the case, we call it impending motion or sliding impends. Let us try to see and prove that this angle of friction phi and coefficient of friction, static coefficient of friction, are related by this equation. We will try to show it very briefly. It hardly takes maybe a couple of minutes. We will try to draw the FBD of the block in one particular situation. Okay, we need to put the heading very clearly here. FBD of the block, free body of the diagram block, in one particular situation, that is when sliding down the inclined plane is impending. Again, you need to pay careful attention to the word impend. Impend means when this angle is slightly less than phi, the movement of the block down the inclined plane does not occur. If this angle of inclination is ever slightly more than this phi, motion occurs. Okay, we note that the direction of movement is as indicated here, going down the inclined plane. So in the block diagram, this is the block. We have drawn the block. Okay, the rectangle. This weight W acts through the center of gravity. Let us say you have a normal force, you have the friction force, which is always tangential to the surface. We see that this angle alpha is related to phi by alpha plus phi is 90 degrees. For convenience, we take x and y axis as shown over here. This is x axis, this is y axis. Okay. the weight is always perpendicular to the horizontal. If this were to be horizontal, the weight W is perpendicular to the horizontal. Now noting these two, we write equations of equilibrium. When we say equations of equilibrium, sum of all x components should be equated to 0 for equilibrium along x-axis. Sum of all y components should be equal to 0 for equilibrium along y-axis. When we say sigma fx is equal to 0, sum all the forces along x-axis. You see that this F is going in a direction opposite to that of x-axis, so we have minus F, and W has a component W cos alpha in the positive x-axis. W cos alpha is W cos 90 minus phi, which is W sin phi is equal to 0. So we have the equation F is equal to W sin phi. Similarly, we sum all the components along y-axis and equate it to 0. One component which is going along positive y-axis is n, so you have plus n here, and W cos phi is the component which is going in a direction opposite to that of positive y-axis. So W cos phi is something going down, so you have a negative. So we have two equations of equilibrium, n is equal to W cos phi and F is equal to W sin phi. To complete this whole problem, we'll try to write one equation of friction. We call it friction equation. Friction equation is given to be F is equal to mu s sin n, where this mu s is coefficient of static friction. It is the constant of proportionality between friction force. Very quickly we need to write Fs, we need to write Fs, we need to write Fs here, and show here also it is Fs. Okay, so Fs is equal to mu s n. Fs, this force of friction we got here as W sin phi. This n we got here as W cos phi. So W sin phi is mu s W cos phi. So W gets cancelled. Sin phi over cos phi is mu s. And so we have our equation, and phi is equal to mu s. So if we know the materials in contact, that is, if we know the material of this rough surface and we know the material of this object, we know what is the moment the material of this surface and the material of the block are given, we know what is the coefficient of friction. Once we know what is the coefficient of friction, we can use this equation to find out what is the angle of friction, that is the angle of inclination of the inclined plane at which the sliding impends. This is what we define to be angle of friction. Knowing this, we say that if theta is the angle of inclination and phi is the angle of friction, which is phi is tan inverse of mu of s. If this is the situation, then we can say that if theta is less than phi, if this angle of inclination is smaller than this phi, the block does not slide down upon its own weight. We need to apply a force which has a component parallel to the inclined plane and going down. So we need to apply a force which is parallel and going down in this direction. A force like this, or a component of force which is somewhat like this, which has a component going down the inclined plane. Until and unless we apply such a force F, okay, such a force, let me say such a force P, the block does not slide down the inclined plane as long as theta is less than phi. Okay, we need to apply a force as shown over here to cause the block to slide down when theta is less than phi. Okay. The other two situations are when theta is equal to the angle of friction. If the angle of inclination is exactly equal to angle of friction, the sliding is said to impede. That is, for values of theta slightly less than W, sliding does not occur. For values of theta slightly greater than phi, the movement occurs, block slides. That is, again we see this as a unstable equilibrium position. When theta is greater than the angle of friction, okay, this theta, if it is greater than angle of friction, the block will automatically slide down. Okay, if we want to stop the block from sliding down, we need to apply a force, something like this, the external force P, which has a component along the plane, parallel to the plane, and going upwards. We need to apply force P to stop the block from sliding down when the angle of inclination is greater than or equal to P. We'll try to solve a few more problems on friction in the next few discussions.